Our next presenter is Justin Hart. He's one of the, almost, your next Andrew. Justin's one of the founding engineers of Ibotta. Back when Ibotta could fit around one of these tables, Justin was working on the back end. He's now our platform architect, and he'll be talking about microservices, secrets management, pain from so many angles.
Sorry for all the noise. All right, I've got a pretty quick talk on managing secrets inside of microservices and kind of how we approached it here at Ibotta. So everybody's got secrets. Obviously, you tried your best to avoid keeping your secrets in plain text or anything, but everybody's got some of them to manage. You've got database credentials, you've got API keys, you've got encryption keys, you've got a number of different things to talk to other systems from your microservice that either are like credentials or secrets to get to that data. So the question is always, you know, is what you're doing safe?
Tell me what to get first.
Oh, I didn't do the sound. Shoot, this was working earlier. That's from Marathon Man. One great scene from that. So you don't, I mean, you want to make sure that your secrets are safe in your container. So what does that mean? That's never storing it in plain text on disk, never transmitting it over the wire in plain text. You want it decrypted on demand. You don't want the secret sort of in memory longer than it needs to be, even. That's just, you know, trying to reduce your attack plane. If you were to have an unknown vulnerability or somebody was to get into your environment, you want to make sure that your secrets are sort of as small as possible on the system, as short as possible. And then accessing your secrets, you want to make sure that you've got good access controls so that only your services and only specific services can get to your secrets. And you want to make sure that you can audit who has accessed secrets in the past. So you want to make sure that you know that this service went and grabbed that database password yesterday and not today because you just decommissioned this service. So that service shouldn't be, you know, going and getting that database password anymore. And if it is, that, you know, somebody else is using it inappropriately. Our requirements for how we wanted to store secrets, manage secrets, is we wanted to have effortless high availability. So this means like either a managed service or potentially something serverless, not having a server in the mix at all. We needed to have the ACLs and auditing that I managed. Decrypt at runtime. We wanted to make sure that we weren't having to bake these things into a compile or into a container. And we wanted to version it with the code. So one of the problems that you run across is that secrets, a lot in some of these systems, you have to know about ahead of time, and then they can drift in different lockstep than your code that's actually using it. So you get into a weird like order of operations thing, especially in like continuous deployment. You want to have simple initial trust. So one of the challenges about secrets is, how do you know who's running your code that has the key to go get your secret? So EC2 has instance profiles, and that's a really easy way because you're trusting that EC2 is doing the right initial trust on their end, that they know that their hardware is running their code, et cetera, et cetera. And you can use like the instance profile to say, oh, I know it's this type of EC2 instance with this right on it, with this role on it. And then we wanted it to be runtime agnostic. We're moving into microservices. We're running Ruby, Java, Python, etc. And we don't want to have to worry about writing a library and everything to be able just to read a secret out of a service or something like that. There's a bunch of options out there. On presentation, there it goes. So HashiCorp Vault is definitely probably the number one well-known service out there. You get to it over an HTTPS protocol. It has various storage backends, provides some ACLs using policies. Doesn't really provide versioning. It stores some history, and you can kind of work through history and get certain history versions if you're using the transport part of it, but then it depends on which storage backend you're doing, and it's kind of complex. Based on your storage backend, sometimes you get HA, sometimes you don't. But it's pretty complex. You're running for HA, it requires a backend which is also a cluster, so etcd or console, and then HashiCorp Vault by itself has another clustering algorithm. So you're sort of in that running a clustering algorithm that has to talk to another clustering algorithm. They do have a backend for DynamoDB now that does support HA, which is nicer. But again, you're sort of having to mix things. Kubernetes secrets. So we're talking microservices. A lot of people run Kubernetes. You can get to those things via environment variables provided to your pod, or as a file that is mounted in your container. Its storage backend is etcd. You get ACLs using RBAC, role-based access controls, but only per namespace. So anything within that namespace that is RBAC enabled can see that secret. On the back end, it does, etcd now does provide storing those things encrypted inside of etcd at rest. That only came about in Kubernetes 1.7, so it's relatively new. So simplicity-wise, it's also sort of a problem, mainly because of you don't get versioning, you don't get those things. CredStash and Confidant both use DynamoDB as their backend. They're sort of an API or a library on top of DynamoDB. Spring Cloud is sort of bring your own. You can plug in a backend, plug in a front end. It's just a library that sort of manages those secrets for you, but it's sort of up to you to provide the API, how it's going to get used. So if you're like everything that you do is Spring Cloud, it's pretty cool. Otherwise, it's kind of a pain. AWS provides this secure system manager parameter store, which is pretty cool. It's its own API. Its backend is probably DynamoDB. Pretty much everything on AWS is DynamoDB at this point. Does provide ACLs using policies. It does provide versioning, at least history, and you can pick out a specific version. And then it's sort of serverless, and it's actually free, which is pretty cool. You get an AWS account, you get SSM for free, which is pretty amazing. So simplicity, yes, but it's still, all of the problem about all of these things is they're not versioned with your code. You have to know about the secret and populate the secret ahead of time before you deploy your app. So again, you're sort of in that order of operations problem. So what we used to use, or we're still using in a couple of services at Ibotta, is Blackbox. It's actually a collection of shell scripts written by the Stack Exchange folks. It uses GPG, multiple GPG public keys to sign and encrypt files, and then anybody in that keychain can decrypt the file, including like a sub key without a passphrase. So setting it up is kind of a pain, especially the deployment part of it, because you have to set up a sub key and it's kind of complicated. No ACLs though, because it's just a file and anybody with one of those keys can download and decrypt. Sneaker, which is Coda, I think, wrote that. It uses KMS and only stores on S3, and it's just like a shell script that wraps that stuff. Mozilla has a program it used to be written in Python, they ported it to Go, called SOPS. It is able to use a KMS key as its initial key data and use that as the source to encrypt files. So you check in the file, you encrypt it, check it into SCM, and you are carrying your files with you. Most of these are that direction. Because it doesn't have a server, I guess KMS it does. That's sort of a server, but it's highly available. It's a global service in AWS, so it's supposed to never go down. And you get it sort of versioning. And obviously you can kind of do something yourself, or do something yourself with key data backed by KMS. Obviously, kind of like anything in encryption, you probably don't want to do it yourself. There's a lot of rough edges. There's a lot of sharp edges that you don't want to deal with, and having somebody else do it for you is awfully nice. So what I wrote, it's a Go project. It's SOPS tool. So one of the problems that we found with SOPS was that it's single file at a time based. And typically you're dealing with multiple files. You're dealing with a couple of different config files, maybe a PEM file for a certificate, something like that. So what I built is a way of managing and sort of wrapping SOPS with some nice stuff that lets you use that SOPS tool, but against multiple files all at the same time. And so written in Go, it's my first actual Go project, dabble in Go, read the tutorials and things like that, but this is the first time I've actually written a program. So definitely has some rough edges, but you can see in this screencast here, I'm using AVS Vault at AVE is AVS Vault exec with my demo account, and using SOPS tool to decrypt a bunch of files. You can see them all get decrypted, and then list out the files so you can see that the files got decrypted, print out the certificate request that was encrypted there, etc. So what does this do? It gives you multiple files versioned along with the code. The idea there is that we wanted to have no drift with deploying a piece of code and its secrets. So the best way to do that is to put it as a file in your code base, but have it encrypted. It JSON encrypts, or for JSON and YAML files, SOPS will encrypt the values, but not the keys of a file. So it makes it easy to diff or just browse through, even though the values are still encrypted. Anything else, it actually encrypts the whole file and actually stores a JSON of it because it has the key information inside of it. But then you decrypt it and you get the file back. So it's using a KMS key with all of the rights and things that you get through KMS, and then AES encrypts the actual values. So there is no size limit as to the type or as to the size of file that you can encrypt. Some of the other tools, including like AWS param store has a maximum either 4K or 40K size limit that you can put inside of those secrets. And sometimes you need to encrypt a bigger file. And then the other thing that this adds is an entry point. So this is really nice. You make this the entry point to your Docker container and have it decrypt the files, run a program. It cleans up the files afterwards all in one layer. So if you've got a build that needs to download packages from a private artifactory or things like that, you can do that through the entry point, and it kind of does all of the stuff for you. I always like to have this. Werner Vogels, the CTO of AWS, dance like no one is watching, encrypt like everybody is. Always encrypt, if you think that something might be sensitive, just encrypt it. Encryption is really easy these days, and services like AWS, SOPS actually supports the GCP KMS. They're building support for the Azure version of it. And it also supports GPG if you're not in one of those environments. So if you have a file that might have a secret in it, just go ahead and encrypt it because it's almost free these days. So that's kind of it. The SOPS tool is ibotta.com/SOPS tool. I have a dot instead of a slash there. And it's definitely open source. It's definitely rough around the edges, like I talked about. I was just fixing bugs in it today, and we'll probably go ahead and cut a release tonight, assuming that somebody approves my PR. But so hopefully, if you're, that gives you some overview of some of the options that you get for managing secrets inside of and maybe a solution. Questions? All right, thanks.